Okay guys, so in this set of notes we're going to look at how to analyze parabolas. Now, from Algebra 1 we know that the equation of a parabola looks like a U, okay? It either opens upwards or downwards, and sometimes they can even open sideways, okay? Opening to the right or to the left. So this is the line y, the curve y is equal to x squared. So that's your parent function for this. As you can see, it has a vertex at 0, 0. And this would be what we call a minimum. Okay, so we're going to talk about maximums and minimums in this section, and finding the vertex and axis of symmetry. Now you have something called the axis of symmetry. So the axis of symmetry is exactly what it sounds like. It's going to divide the parabola into half, okay? It always goes through the x-coordinate of your vertex. Now, the general form of a parabola is y is equal to ax squared plus bx plus c. Most of the time, the most useful form for this is going to be if we put it in what we call vertex form, okay? Where the vertex is given by hk. Now, to get it in this form from here to here, you're going to have to complete the square, okay? So that's why we spent so much time on completing the square the last lesson. The line of symmetry that divides a parabola in half is called the axis of symmetry. We already talked about it. Now, if the number in front of the x squared term, the a, is positive, it's going to be opening up. So this is called concave up. We're going to use that terminology in calculus. So it's going to open up. It's going to open downward if a is negative. Okay? So what we're going to do is we're going to do our best job to find the vertex, axis of symmetry, the max and min values, the domain, the range, and the direction of the opening. And then we're going to graph the function. Okay? So, first one, y is equal to x squared minus 4x plus 1. We're going to complete the square. So we complete the square. We're going to put our plus c in, and we're going to kick out that 1. We're going to do b over 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So if I put in a plus 4 on this side, I have to take 4 away right here. So as y is equal to x minus 2 quantity squared minus 3. Okay? So to go from here to here, we square root the first term, keep the sign in the middle, square root the last term. Now, from here, we're going to identify our vertex. So your vertex is going to be at the point 2, negative 3. So pretty much just change the sign of whatever's with the x, okay, in there. Your axis of symmetry goes through the x-coordinate. X is equal to 2. So since it opens upwards, you're going to have a minimum. Okay, so your minimum value is always going to be the y-coordinate. Okay, value means y-coordinate, so it's going to be negative 3. Your domain for a parabola is always negative infinity to positive infinity. Your range, since we have a minimum value, it's going to go from negative 3, close brackets, because it's equal to infinity, and it's going to open up. Now, when we're graphing parabolas, to get a good idea of what it looks like by hand, it's not always going to work out with nice numbers, but a lot of these do. So I'm going to plot my vertex to negative 3 in the middle. And I'm going to pick 2 points above and 2 points below, 3 and 4, like that. And I'm going to plug in to either form of the equation, okay? So if I plug in a 0. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. If I plug in a 1, 1 minus 2 is a negative 1. Negative 1 squared is 1. 1 minus 3 is a negative 2. And it should be symmetrical on this side. 3 minus 2 is 1. 1 squared is 1. 1 minus 3 is negative 2. 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1. Okay, so we're going to go plot our vertex first. Our vertex is at the point 2, negative 3, 1, 2, 3. And then something like that. And the point 0, 1 right here. And the point 4, 1 is right here. So I'm not asking for it to be perfect. Most of the time, when we're graphing stuff like this in calculus, we're just looking for the general shape of the graph. Maybe the x-intercepts would be useful. But anyways, this is how you complete the square to analyze a parabola. Okay, next example problem. We have a negative x squared plus 2x plus 3. So we have to factor out that negative sign when we go to complete the square, just like we did in the previous lesson. And we're going to kick out the 3. Complete the square. Negative 2 divided by 1. Negative 2 divided by 2 is a negative 1. A negative 1 squared is 1. Now, 1 times a negative 1 is a negative 1. So I have to change the sign. So this would be a plus 1. So if I'm putting in a negative 1, I have to add 1 over here. Breaking this down, factoring it, becomes x minus 1 squared plus 4. Square root the first term, keep the sign in the middle, square root the last term. Now, my vertex is going to be the point 1, 4. Change the sign right there. Okay. Axis of symmetry goes through the x-coordinate. Make sure it's the line x equals 1. You have to put the x equals. So since it's opening downward, it's negative on front, we're going to have a max. Your max value is going to be 4. Your domain. Domain is always negative infinity to positive infinity. What else we got to find? The range. Okay, so your range is going to be negative infinity to 4, because that's your max value, and it's going to open down. Okay, so let's make our little t-chart. We're going to pick 2 points that surround it, so 0, negative 1, and 2, and 3, like that. And so we're going to plug in a negative 1. Negative 1 minus 1 is a negative 2. Negative 2 squared is 4, so it should be 0. Just double check this in my calculator too, because I'm going quickly. And I'm not all here this morning, so. Okay, so you get a 0. If I plug in a 0, 0 minus 1 is negative 1. Negative 1 squared is 1. Negative 1 plus 4 is 3. Okay, and it should be symmetric on this side. Okay, so we're going to go start by plotting our vertex at the point 1, 4. And 0, 1, 2, 0, 1, 2, 3. Okay, so it's symmetric like that. And let's get a decent graph that looks that. Okay. Next one. Y is equal to 2. We're going to factor out that 2. Put our plus c, and we're going to kick out the negative 3. Make sure you don't forget to divide that middle number. Okay, so completing the square. 2 divided by 2 is 1. 1 squared is 1. So I'm putting 1 times 2 in, that's 2. So I have to take a 2 out. So I get y is equal to 2 times x plus 1 quantity squared minus 5. So my vertex is going to be the point negative 1, negative 5. I changed the sign here with my h. Your axis of symmetry is the line x is equal to a negative 1. You're going to have a min value because it's going to be opening upward. This is positive, so you got a min value. X is equal to -5. Your domain is -infinity to +infinity. Your range is going to be, this isn't, sorry. Min value is just -5. I don't know why I wrote that. Okay, so your range is going to go from -5 to infinity. And it's going to open upward. Okay? So make sure that if it opens upward, you know you're going to have a min. If it opens downward, you're going to have a max. Okay, so let's make our little t-chart. And I am going to plot the point -1, -5. Now let me show you how I'm doing this in the calculator. So I'm going to put the original function into y equals 2x squared plus 4x minus 3. And I'm going to build my table. So I'm going to pick the value 2 above and 2 below. So -2, -3, and 0 and 1. Okay, so I'm going to have my table on ask, the independent variable on ask. We did that before. So we're going to do -3, -2, -1, 0, and 1. And that's how I'm getting my values. So make sure you're plugging in this and doing it mentally. It'll help you. So -3 plus 1 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. -2 plus 1 is a -1. -1 squared is 1. 1 times 2 is 2. 2 minus 5 is a -3. And these should be symmetric. Okay? So, we're going to plot our vertex first. -1, -5. 1, 2, 3, 4, 5. And then 0, -3, 1, 2, 3. And then the point -2, so it looks like that. And then 1, 3, 1, 2, 3. And the point -3, 3, 1, 2, 3, 1, 2, 3, like that. So our parabola looks like this. Okay, now I don't expect you to go to the calculator and just sketch the graph if you hit graph. I expect a table and to come up with 5 key points. Okay, golly, I've got a lot of examples for this. Okay, next one. So we get y is equal to a -3 times x squared plus. Now, if I'm factoring out a -3, I have to divide. So this is going to be a -4/3 x plus c. Okay, so we're going to complete the square. So 4 divided by 3. So 4/3 divided by 2 is 2/3. And then I'm going to square that. And I should get 4/9. Okay, so if I put 4/9 in, I have to multiply by the -3. So that comes out to be a -4/3. So if I put a -4/3 in, I have to put 4/3 outside over there. So we're going to factor this down. Keep the sign in the middle. Square root of 4/9 is 2/3. Okay, so your vertex is going to be the point 2/3, 4/3. Your axis of symmetry goes through the x coordinate. Is x is equal to 2/3. This is going to be a max value because it opens downward. So your max value is going to be 4/3. Your domain is -infinity to +infinity. Your range is going to be negative infinity to 4/3 because the max. And it's going to open downward. Okay, these points are going to be a little weird, so because we've got fractions, so we're going to do our best on it. So 2/3, 4/3. So I suggest you do like, let's do 0. So this one, I would get a point on each side just to be safe. So let's do 0. If I plug in a 0, get a 0. Let's do, I think 5/3. Let's do like 5/3. Okay. So 5/3. That's a 1, -3. And what's messed up about this one is it's a fraction, so it's gonna throw everything off. If I could type into my calculator to make sure I'm getting the right answer. Okay, so plug in 0, 0. Okay, 5/3. So you get -5/3 on that side. So so we're gonna have the point 0, 0, the point 2/3, 4/3, something like that. The point 5/3, -5/3, just like right here. Okay, so your vertex is right there, so something like that. We're not going to get super picky on that one. And on your test, I won't make you do anything that deals with fractions and graphing like that. Okay, so y is equal to 1/2. We're going to factor that out, x squared. When I factor out a fraction, I have to multiply this. So minus 2x plus c. This one will probably be a lot nicer with the fractions. Okay, so we gotta do our c. -2 divided by 2 is -1. -1 squared is 1. Okay, so if I put in a 1/2, I have to take out a 1/2 over here. And this is what it's gonna factor down to and simplify to. Okay, so our vertex is gonna be the point 1, -9/2. Your axis of symmetry is x is equal to 1. It's going to open up, so we have a min value of -9/2. Your domain is going to be -infinity to +infinity. Your range is going to go from -9/2 to infinity because we have a min value. What else? So it's gonna open up. Okay. So we're gonna graph this. Okay. So we're gonna put this 1, -9/2. We'll go above it 0, -1, 2, and 3 like that. So if I plug in a 0, I should get a -4. So this should be a -4 also. And plug in a 3. Okay, so plug in a 3. 3 minus 1 is 2. 2 squared is 4. 4 times 1/2 is 2. 2 minus 9/2 is -5/2. -2.5. Now, let's just show you how I'm doing that real quick in the calculator. So let's put the original in there, 1/2 x squared minus x minus 4. And there's no shame in checking your work in the calculator because I do it all the time. Okay, so those are going to be our key points right there. Okay, so we're going to plot our vertex. 1, -9/2 is 3, 4, wait, 1, 2, 3, 4.5. Like that. So the point 0, -4, 1, 2, 3, 4. And then we're at 2, -4 like that. And then -1, 5/2 is 2.5. 2.5 like that. Okay, I don't know if you've noticed that. Okay, if your A is less than 1, it's going to be a wider graph. See, this is a little bit wider. If your A is greater than 1, it's going to be a thinner graph, like it'll be squeezed closer together. Okay, that's called a stretch or a shrink. I'm so over the square right now. Okay. Last few. Okay, so we got y is equal to 3 times x squared minus 4x plus c and minus 4. So we're going to complete the square. -4 divided by 2 is -2. -2 squared is 4. 4 times 3 is 12. So if I put 12 in, I have to take 12 out. 3 and x minus 2 squared minus 16. Okay, so your vertex is at the point 2, -16. Your axis of symmetry is the point x is equal to 2. Since it opens up, we're going to have a min value. Your min value is going to be -16. What else? We're going to do domain. Is always -infinity to +infinity. Your range, since it's a min value, it's going to be -16 to infinity. And it's going to open up. Okay, so this one's going to be a little weird because your vertex is going to be off the graph. So no worries, we're just looking for a general idea what it looks like. Okay, so if I plug in a 1, 1 minus 2 is -1. -1 squared is 1. 1 times 3 is 3. 3 minus 16 is a -13. -13. And if I plug in a 0, I should get -4. Okay, and this should be a -4. Okay, so let's do our best to plot these points. So 2 and 16. Let's say it's down here. And then 0, -4, 1, 2, 3, 4. And then the point 4, -4, 1, 2, 1, 2, 3, 4, 1. So our parabola is going to look something like this. You notice it's going to be thinner because of the 3 in front. Okay, next one. We got y is equal to x squared minus 2x plus 3. So we're going to do x squared minus 2x plus c. Did we do that wrong? Oh, we did one somewhere to it. Okay, plus 3. Now we're going to put in our c. So -2 divided by 2 and squared is 1. So if I put in a 1, I have to take a 1 out. Okay, so vertex. So your vertex is going to be the point 1, 2. Axis of symmetry is going to be x is equal to 1. Since it opens upward, it's going to have a min value. Your min value is going to be 2. Your domain is going to be -infinity to +infinity. Your range is going to be so 2 to infinity, because min. And it's going to open up. Okay, so these should be nice points to deal with on this one. Okay, so we're gonna put 1, 2 in here, 0, -1, 2, and 3, like that. Plug in a 0, you should get 3, 3. Plug in a 3, 3 minus 1 is 2, 2 squared is 4, 4 plus 2 is 6. So our graph, so let's see, 1, 2. 6. 1, 2, 3, 4, 5, 6. Like that. And that's what it looks like. Okay. The last few, we don't have to complete the square on. So our vertex, in this case, okay, is the point 0, -6. Your axis of symmetry is x is equal to 0. We're going to have a min value of -6. Sorry. Your domain is going to be -infinity to +infinity. Your range is going to be -6 to infinity. And it opens up. Okay, so we can use our knowledge of parent functions. The graph y equals x squared goes to the origin. Okay, now if you want to shift it down 6, because that's what this says to do, 1, 2, 3, 4, 5, 6. So that's where your vertex is, and just for sake of clarity, let's do our points so I don't mess you guys up. So if I plug in a -1, a -1 squared is 1, 1 minus 6 is a -5. Plug in a -2, -2 squared is 4, 4 minus 6 is a -2, -2. Now it's important to know what these parent functions look like so you can graph this stuff easily, especially on your SAT. This does show up on your SAT. Okay. Next one, we don't have to complete the square. Your vertex is the point -1, -2. Your axis of symmetry goes to the x-coordinate is x is equal to -1. This is going to be a min value because it opens up, so your min value is going to be -2. Your domain is going to be -infinity to +infinity. Your range is going to be -2 to infinity, and it opens up. Okay, so this is going to be a super thin graph because the 8 in front. Okay, so let's do -1, -2, and let's pick -2, -3, 0, 1, like that. Okay, so if I pick the point -2, so -2 plus 1 is a -1. -1 squared is 1. 1 times 8 is 8. 8 minus 2 is 6. So that's what those should come out to be. And then if I plug in a -3, a -3 plus 1 is a -2. -2 squared is 4. 4 times 8 is 32. 32 minus 2 is 30. So you can see what I'm talking about right there. Okay, so we're pretty much just going to plot those 3 points. So we're going to plot the point -1, -2, and 0, 6, 1, 2, 3, 4, 5, 6. And we're going to plot the point -2, 6. Okay, so it's just super thin graph like that. And like I said, I don't expect it to be perfect. Okay, last one, your vertex. is going to be 1, 3. Your axis of symmetry is going to be line x is equal to 1. Since it opens downward, you're going to have a max value of 3. Your domain is negative infinity to positive infinity. Always for parabolas, your range. Since that's your max value, we're going to go negative infinity to 3. And opens down. Okay, now we're going to graph this. Let's do our table. We're going to pick our 0.13, put that there, 0, -1, 2, and 3. So plug in a 0. 0 minus 1 is a -1. -1 squared is 1. 1 times a -3 is a -3 plus 3 comes out to be 0. So that should turn out to be the same thing. And then -1 minus 1 is a -2. A -2 squared is 4. 4 times a -3 is a -12. -12 plus 3 is a -9. Okay. And we're going to plot our vertex is the point 1, 3, 1, 2, 3, 0, 0, and 2, 0. And then -9. Something like that. And we're going to connect the dots. And my parabola looks pretty bad on its side. But that's what it looks like. Okay, so this has been graphing parabolas and analyzing parabolas. We're going to come back and do another section where we're given the graph and how to find the equation of the parabola. So hopefully this helps for your SAT and any of the other standardized tests that you're expected to know, Algebra 1, Geometry, and Algebra 2. Thanks, and have a good day.